Hi everyone, in this recording we're going to discuss the general update pattern. So the last recording's material would be enough if we were just trying to create static visualizations. We could just take a data set, bind it to a bunch of HTML tags, append those, and set their attributes. But then in a lot of interactive visualization, we need to change the HTML somehow, right? You can imagine if there were a drop-down menu and they're selecting different options, we might need to change the points that are displayed. Or maybe they want to draw brush over points, and then as you draw the brush, you want to change the color of the selected points, right? So we might need to either add or remove elements, or we might need to take existing elements and change their properties. All of these are handled by D3's general update pattern. So first, remember, when we do a data bind, we're associating an array with a whole bunch of HTML tags. When these sort of interactions happen, three things can happen, right? You can either have a lot more elements in your array. So you might have said, I'm interested in all these other data points as well. You might have filtered down the array. So you're saying, I only actually care about some smaller number. Or you might have changed some attributes. So maybe there's some attributes saying whether the point is highlighted or not, and that might have changed according to the user interaction. So in any of these cases, the data in our array is different from the data that we originally used when we bound the HTML tags. So now we need to have some way of taking those HTML tags and updating them to reflect the new data, either more elements, fewer elements, or changed elements. To work with the more or fewer elements, we can use these .enter or .exit functions. So .enter is going to do the calculation where it looks and notices there are actually more data elements than we have HTML tags. It's going to be what allows us to append new HTML tags. .exit is going to notice when there's a kind of shrunken data set compared to the HTML tags. Let's look at this concretely. What does this code do? This is just creating an array from 0 to 9 and binding that array to a selection of circles. Since the circle's selection originally is empty, when I do .enter, it's going to notice that difference and say, okay, I need to create 10 new circles. Append actually creates the tags for all the circles, and adders is setting their locations. This is saying, D is just going to be 0 through 9. So the first one is going to be at x coordinate 50. The second one is going to be at x coordinate 100, and so on. So this code just leads to this visualization. Okay, so far this is just like data binding. What if, according to some other user interaction, they decided they're going to append 3 new elements to this array? It's going 10 through 12. How can we create new entries? Or how can we create new circles on our plot? One thing to do, you could just rebind the entire data set and redraw all the circles. And that would work. But that's very inefficient. And especially when you have lots of points already there that you don't need to change, this is going to slow down your visualization unnecessarily. So a better strategy is to rebind the data. When you rebind the data, you can recognize that there's 3 new elements using .enter and only append those entered elements. That's exactly what this code does. It reselects all the circles, but then when it makes this data bind here, it's going to be able to recognize that I only need to append 3, because the difference between the existing selection, which already had 10 HTML tags, and this new array, which has 13 elements, is going to recognize there's a difference of 3 new HTML tags that I need to create. And those are created by this append. This attributes is the same as before, except I'm now filling the entered circles in red. So you can see here are the 3 red entered elements. Okay, so we can do the same kind of idea for slicing. So, or for exits, right? So when I slice, I'm removing 3 elements. So now when I do my select all and my data bind, I recognize when I do the select all, I have 10 HTML tags. But when I bind the data, I only have 7 elements in my array. So this exit is recognizing, okay, there are going to be 3 elements that I potentially need to remove. here I'm just shading in those 3 elements that it's considering to remove, because it just looks at the last few HTML tags and it recognizes the difference in the sizes. So it's going to plan on removing those last few HTML tags so that the number of tags matches the number of elements in this array. Okay, so that's kind of one important point to recognize. It's using the array indices a lot, right? It's just comparing the length of the array with the number of HTML tags. It doesn't actually associate any specific element on the page. Like if I had ordered them in some random way, it's still just going to look at the last HTML tag, and if there's a difference in the size, it's just going to remove the last HTML tag. This might be a little bit problematic if you actually want to remove an intermediate HTML tag, so it's like a middle circle. So we're not going to talk about that now, but in the next lecture we'll see some example of how you can specify specific HTML tags to remove rather than just trying to do the length calculation. Okay, so that is actually the main idea of the general update pattern. The thing that's often useful is to create some sort of transition. So this is just like a nice bonus that you can do once you know how to do entering and exiting. So here I'm doing the exact same kind of code as before, except when I append it with radius 0. So it's just like an empty tiny circle. And then I'm going to wait 2000 seconds before I increase the size of the radius. Okay, so actually I need to refresh the page so you see. Okay, but the circles, they grew. So it took the existing ones were already there, it didn't make any change, but for the entered ones, it gradually entered them in. And you can do the same thing with exits. So here I'm taking my exit, I'm waiting 4 seconds, shrinking them down, and then completely removing them from the page. And that's what the dot remove does. Right, so they shrunk down and they disappeared. Okay. So now there might be situations where it's not really, you're not focusing on just the entered or removed data entries. You just want to change entries that were already there, right? So, so one thing you can do, you can try just selecting everything again and then setting attributes on everything you've selected. And so that's what I'm doing here. I've entered the new circles, and when I select all here, it's going to select all 13 circles. So it's all 13 and it's set them all to red. This can be kind of inefficient though. And sometimes you really do want to distinguish between the elements that are just entered and the elements that were there before, but which you might need to change somehow. You might need to change their attributes. For doing that kind of comparison, where you really need to distinguish between things that are changing but which are there and things that are brand new, it's helpful to use this .join command. This is actually only in the newer versions of D3, but it's kind of considered the best practice when you need to change in this way. It's similar kind of logic. The way it works is you have this .join function, and then within the .join function you enter or you create these separate functions. Each different function is one argument. If you have a function where its argument is called enter, then it's going to apply it to only the entered elements. So the ones that were not in the HTML tag, but which just became available in the data join. So, right, I've just appended these 3 new elements, so now this array is larger than the original SVG. And then if I give it a key with update, it's going to look at everything else. It's going to look at everything that was already there, and it's going to allow you to change attributes of everything that was already there and not entered. So here I'm setting all the entered circles, so that's 3 new ones, I'm setting them as red, and then the updated ones, the ones that were already there, I'm just changing in blue. Okay, so this is still all kind of a toy example, but hopefully you can see it's not too hard to be able to track changes in these data arrays and update your visualization accordingly.